What's going on, everybody? Zane here, back with another video. For this one, we've got question number 694, which is the number of distinct islands problem. So this is similar to the max area of island or the number of islands problem, where we're essentially going to be going through our matrix. We get to a specific value, then we'll run some sort of DFS function, and that DFS function will account for all of the directions, the horizontal or vertical, up, down, left, right, and then it'll return some value for us. So for this particular question, we have the distinct islands as our major issue, where we're given an example like this. We see two islands that look identical. And so even though there are two sets of islands, we want to return one here because it's only one distinct island. So how exactly do we establish whether or not something is a distinct value or a distinct island? In this case, we could say, hey, if there's two squares of equal lengths and widths, then hey, we can probably return that it's just actually one. But how could we translate that into code? I was doing some research, in an excellent way that kind of blew my mind that perhaps could be used for other problems was using some sort of unique identifier. And by using some identifier or some path, we can establish what a island that is distinct will have as its identifier. And I think the best way to actually go about understanding that is going through the problem. So our first thing is always going to be, we need to loop through our grid. So we'll do a basic for loop on the rows and the columns. J is going to be less than grid at I dot length, then J++. And now we'll say that if the value that we're at in the grid is equal to 1, that means we're at an island or a potential island. So what we can do now is some sort of DFS call. So typically what we would do is we'll say DFS will pass in our grid and our I and J values, because those are the only values that we're really working with right now. And in this case, we need to have a unique identifier. So in this case, I'm going to rename DFS, because what we're going to be doing is the DFS function is actually going to create a unique path for us. So I'll name this compute unique path. And this is going to take in the grid, I, J, and one more value. And that value, we'll just call this Z. Just because Zane, Z41N, I'm just going to go with Z. And the reason we're going with Z is because, or any particular string, is because this is what's going to compute some string path for us. So after recursively going through this function, it'll compute the path for us. And then what we could do is one additional step where we could add this unique path to a set. And a set is, of course, going to be non-duplicates. It's always going to be unique values inside of a set. That's just a property of it. So if we add all of our unique paths to our set, then the number of distinct islands will just be the size of the set. So let's go ahead and create our DFS function, which is just going to be our compute unique path. This is going to return a string value because we're going to compute the actual path, and that's going to be a string. And I'm using Z here because it's just a dummy value. So in our parameters, we're going to pass in an int matrix called grid, an int I, int J, and we're going to have some string, and it will be, let's just call this direction. So you know what, maybe instead of Z, let's just call it X, because X marks the spot, we're at an island, blah, blah, blah. So X is going to denote the fact that we're at a particular island. So now what we can do is our basic checks. So since this is a recursive call, we need some sort of base case or edge cases to make sure that the recursive call doesn't go into overflow or out of bounds or whatever. So we'll say if I is less than 0, out of bounds, J is less than 0, that's also out of bounds, or I is greater than or equal to grid.length, or J is greater than or equal to grid at I dot length, or the value that we're at right now is not 1. That means we need to return some value. So since we're returning a string, let's just think about what should we return? Well, if we're going to be creating some unique path, that's going to use the letters left or L, R, U, P, or UD, because up, left, down, right. So if we are at a situation where we do hit an X, or do hit a island or a 1, we're hitting X. If we're doing left, we're doing L, right, R, up, U, down, D. So if we're at a situation where we haven't hit an X or any of those other letters, then let's just go with the letter O. So now if that's ever the case, it'll return the letter O. Now, what we could do is we can create some path. So we'll say string path equals an empty string. Now, what we could do here is we'll set the value that we're at right now to 0 so that we don't account for it again. And then we can start adding our unique paths. So our path is going to be whatever the recursive call of our function is going to be. So in here, we're going to pass in our grid, we're going to pass in I, we'll pass in J, and our direction, if it's going to be up. So if I'm going I plus 1, then it's going to be a U. I want to give this a unique string of U if we're going up. Now we need to do this 3 more times, so let me just paste these here for now. So up is going to be U, so let's do down, so that's going to be D. If I take these out, now if we're going up on J, that means we're going right. And then if we're going down on J, we're going left. And now what we'll do is we'll return our path. Now our path is going to be, if we were to just go through this again, right? This is a function that's going to return a string. So we're just making sure that if it's ever out of bounds or if it's not a 1, then just return O. That'll be our path. And then if that's not the case, we'll just create or initialize some path variable, set this to 0 so that it does not count for itself again. And then we'll say that the path is just going to be whatever the path usually is if we went I plus 1, I minus 1, J plus 1, J minus 1, and then return whatever the path is. So this will essentially compute what our unique path is recursively. Now, once we've gotten our path computed, we can go back up here and we can say string path equals compute unique path. So it's returning a string, so we can just throw it into some variable. And now we want to add our path to our set. So we're going through all of our values in our matrix. So every single time we hit a 1, we generate our path and add it to our set. So we'll create a set of type string because that's of course a string path. We'll call this set. And we'll say that this is a new hash set. And then down here, we've already created our path. Now we can say set.add our path. And then lastly, we just return the size of our set because anything inside of our set is going to be unique always. So however many items are in our set, that must be the number of distinct islands. So let's just run this, make sure that we're good to go. Was accepted here. Okay, so there is an issue, and I think I know why, is because if we go down here, we're always going to be starting off with our X value. So our X value is our direction, the direction that we're going in. So to make sure that we account for that X, we want to add our direction before our path. Run that, and there we go. So here really what we're doing is we're creating a unique identifier for our distinct island, and depending on what that path is, we'll add that to our set and then return that to our function as our number of distinct islands using the characteristics of a set and generating a unique path. Anyways, that's it for this one. If there's any questions, comments, feedback you guys have for me, please let me know in the comments below. Otherwise, hit that like and subscribe button, show me some love, and I'll see you in the next one. Peace.